Here we go. So I want to establish all three of these identities. This one is one of the basic ones that we derived yesterday. So we'll go ahead and we derived sine of x over 2 yesterday, so we'll derive cosine of x over 2 today. So what do you guys think about this one though? Which side should we start on?
The left side.
Yeah.
Sure, okay. It's 113.5. It's going to 6.75.
So what do you think the first step is?
Right.
Separate the cosine to x into cosine of x plus x.
You could do it that way, but let's assume that we remember from yesterday what the cosine of double x is. Remember there were three versions, there's just one you want to remember.
1 minus 2 sine squared x.
Cosine of double x from yesterday is cosine squared minus sine squared. You should remember that version. You guys all seemed on the first quiz pretty comfortable with converting these guys into 1 minus sine squared or 1 minus cosine squared. You can do that to get its other versions. So let's see. If we do that, our answer doesn't have any cosines in it, right? So I'd probably want to get rid of this guy doing what I just said.
You would use 1 minus 2 sine squared x.
You mean 1 minus sine squared x? Yeah? So we're going to have 1 minus sine squared and then another sine squared. So you're right. Except that's where that came from. Yeah? That's where we got that yesterday. Yeah? You don't want to remember that. Remember this more basic thing. Yeah? I mean, I guess it's up to you, but if you do that, what happens on this one? You distribute. 1 minus 1 is gone. Minus minus is plus.
It's 1/4. So he's got pixels.
And there you go. All right, let's look at the middle one. What do you guys think about the middle one?
Oh, it's having +1 then. I think do it and you double check that.
Which side do we want to start on? I think it's a toss-up here. We could start on the right. There probably is a little more to work with. I'm going to just defy tradition, though. And today I'm going to start you on the left, okay? So just another way to do it. You guys are probably right. Starting on the right is probably a better way to do this. So I like that, but let's do it on the left because I just want to take this another way today. So tangent squared is like sine squared over cosine squared. You could go 1 plus secant squared, but I'm just going a specific route with this one today, okay guys? I'm not saying it's the easiest way to go like we usually pursue. Because I want to remember that we can use other versions of sine squared and cosine squared. Yesterday we derived some of those other versions, so let's go through that derivation process again. It's not the easiest way to do this problem, it's a productive way to do it. So going back to yesterday, remember we learned that cosine of 2x, or double x, was what? We just wrote it down again a second ago.
Cosine squared x minus sine squared x.
Okay. So we know that.
It's just plus. Right.
So that has a cosine squared and a sine squared in it. That's a way to convert sine squared and cosine squared, which is really useful later.
Have you seen the color story?
So if I want to convert sine squared, then I better turn this one into sine squared, just like we did a second ago. Using Pythagoras. So that says cosine of double x is equal to 1 minus 2 sine squared, just like we had a second ago on that other problem. This is an argument you should be able to go through. So now I can solve for sine squared here and I'll have something to substitute there. So I'm going to have cosine of double x minus 1 is negative 2 sine squared x. That's cosine of double x minus 1 over negative 2 is sine squared x. That's really ugly, so I'm going to turn it around. I'm going to put the minus on top and say that that's 1 minus cosine of double x over 2. That's another way to say sine squared x. That way right there is extremely useful for all kinds of different things. So it's an identity that you either want to memorize. I think it's more useful to just memorize this and the argument that you can go through to get it. Okay? That's just one thing you need to remember, then you do stuff. Okay? So that means that I can write the top as 1 minus cosine of double x over 2. You can go through the exact same argument, and if you're watching the video right now, I'd really encourage you to go back to right here and solve this thing now for not sine squared, but we need also cosine squared. Go through this argument. It works the same way for cosine squared. What you're going to get, I'll do it in green, is that cosine squared is 1 plus the cosine of double x over 2. Now if I flip that, what's going to cancel? The 2's. You're going to have this left. It's kind of a more roundabout way to do this identity, but an extremely productive one. Okay? So if you go through that argument, you'll be paid off in the future. It's kind of like saving up in a bank. Okay, yesterday we also tried to establish the half angle identities like cosine of x over 2. The book just kind of brings this out of nowhere. Where does it come from? I think it comes from the same kind of argument that we're using right here. So instead of looking at the cosine of plane x over 2, I'm going to start by looking at the cosine squared of x over 2. Because just a second ago I told you what you could put in for cosine squared of something. What was it? I have a certain color marker in my hand.
1 plus cosine.
Something's not quite right though.
It has to all be divided by 1.
That was cosine squared of x. This is cosine squared of half x. So I need to put half x right there. And 2 times half x is x. So this is 1 plus the cosine of x over 2. So if cosine, I'll write it down right here. If cosine squared of x over 2 is that stuff, and you want the cosine without the squared, you can treat this like an equation pretty much and square root both sides so that you get that. If you square root both sides, you got to put a plus or minus. That's where that came from. Okay. This all goes back to knowledge, remember, that we already had. This goes back to manipulating the cosine of double x, and that we got from going cosine of x plus x, like Emma was telling me at the beginning of class, using our cosine of x plus y identity. Okay? Let's look at a couple more problems. Okay, so this time, another one of these given problems. There's definitely going to be at least one of those on your next quiz on Tuesday. So, cosine of x is supposed to be negative 5/17. And I know which quadrant it's in. What's this say about its quadrant? Quadrant 3 is what this says in other words. So let's draw x in quadrant 3. Yeah. Negative 5/17. If I try to make it look realistic, it might look like that. Right? Or angle x. So how do I find the missing side of my triangle again? So I go like 17 squared. What is this? I think it's 289. It's 289. Subtract 25 on both sides. What are we going to get? 264.
I have a minus.
So we won't reduce that. We'll just leave it.
Why do we have a change?
Why did I put it as negative? It's obviously down there, right? Okay. So we've got our reference thing. How would I use that to find sine of double x?
-3 e to the x. Yeah.
First, I've got to remember the identity. And this is one you want to memorize for sure. It's easy. It's 2 sine cosine. We know x. That should be easy. Right? So we got 2 sine is going to be...
Good answers. I got -2 e to the negative x.
And cosine we know.
E to the negative x minus 1.
So that's going to be negative times negative is positive 10.
E to the negative x minus 1.
So sine is positive. Now, let's try to think about, that's not a lot of information, but is that enough information to know where double x is? You guys, thank you. Sine of double x, if it's positive, that means it's either in this quadrant, because sine is y, or this quadrant. So if x was right here, what do you guys think is more likely? When you double it, are you going to get all the way to there? Or are you going to get to there? Think about it. If it was like right here even, if you doubled that, would you get back? I don't know if we have enough information here. I'm thinking first quadrant like Emma, but I'm not sure. So how would I get more information for double x? I'd have to do like cosine of 2x. Let's just do it. We've got the chance, so let's do it. So cosine double x for this x is going to be this, right? We've got those things. Cosine is sine is so it's going to be 25. Is that negative or positive? It's going to be negative, right? Negative 244.39. So, which of these two quadrants is cosine negative in? That one. I was thinking it was going to be 1 as well. Think about it. If the angle was right here and then it's all the way to there, and you double it, it could, I think, go all the way back up there. So there you go. There's 1. Now I want to look at half of x and the tangent of half of x. This is not a thing you need to memorize. What is this? Can you guys pull it out of the book? There's several versions. Give me one of the easy versions. There's one with a square root in it. I don't think you want to use that one. Use one of the other ones. There's one that's like tangent plus 1 over 2 or something like that. Sine plus cosine over 2, something like that. Help me out. We're going to need our book out in a second anyway, so I'm going to grab your book if you don't already have it. I see one that says 1 minus cosine over sine. There's a couple versions. Use which one you like. I'd use one of the easier ones. So for this guy, we're going to go 1 minus cosine is going to be negative 5 over 17. Sine is negative root 264 over 17. So that's going to be 1 plus 5 over 17. Common denominator time. So we're going to have 17 plus 5 over 17 over stuff. I'm just going to flip that stuff right now.
Like what we have.
17 plus 5 is 22. That's clearly a negative number. So do we need enough more information on this one to decide where half of x is? I don't think so. Because if x is over here, half of x has got to be in one of these quadrants, right? That tells you which one. Because tangent is negative in what quadrant? Well, nothing's negative here. It's got to be here. So this guy, x over 2, is in quadrant 2, which I think makes sense with what we just got for double x, because if double x turned out to be all the way back there, that means x has to be a big angle here. And if x is a big angle here, like, I don't know, 240 degrees, what's half of 240? 120. That's there. So I think this definitely makes sense. All of it together. Okay. One last question for today. Let's prove a more interesting identity. I probably should say what it's equal to. So you have those other last identities. You don't need to memorize any of them. The product to sum identities and the sum to product identities. They're just some other identities. Use them out of the book. Which ones are going to be useful here? And oh yeah, by the way, which side do you guys think we want to start on? The big side. So we're going to say, starting on that side, see if you guys can find the right identity and help me out here. So, are these going to be sum to product or product to sum? Well, what do we have? Do we have product or do we have a sum?
No, it's great.
Well, we don't have either one of those really, right? But it's not a product, it's a difference. Differences are like sums. So I think you should have an identity in there which tells you how to go sine of x minus sine of y. Help me out. How's it go? 2 cosine. Okay, so for us, x plus y over 2, what is it? It's 3t plus t over 2. And then, is it times sine or times cosine? So times sine, and we're turning it into a product, and then how's it go?
X minus y over 2.
X minus y over 2. There's the top. A sum, or in this case a difference, was turned into a product. Basically, we're factoring it. And on the bottom, I think there's one for cosine minus cosine as well. Caleb, give me that one. Somebody else give me the other one.
Oh, you just split it.
X plus y over 2.
Sine it's minus 2 plus negative 0.9.
So I have no idea if you guys gave me the right ones. I'm guessing you did. We'll find out.
6, 1.
So some stuff cancels here, right? Then we've got cosine of 4t over 2 is 2t. 3t minus t is 2t over 2 is t. Down here we have a minus sine of 4t over 2 is 2t. And then a sine of t. Those do totally just cancel out, so now we have a product. So then we've got cosine over sine. Oh, and the stuff inside is the same stuff, so that's negative cotangent of 2t. So, one thing I want you guys to be aware of, because like I have some pretty tricky questions that I've put on a couple of these quizzes, all your other identities can still appear during this process. So for instance, if you were doing one of these problems and you had something like the cosine of negative 2t, and you needed to change it into other stuff, What could you do with cosine of negative 2t? You have a lot of options. First, you know about cosine of negative angles. What happens to the negative? It goes away. And you also know about cosine of double angles. Like on this one, we got to what we wanted to prove. But what if what you wanted to prove didn't have a cosine of 2t in it? You know about double angles. I think we just did it like 3 times. You could change this into what?
Cosine squared.
So that is
minus
beta is also.
You might have to do that sometimes. If you had something like on the bottom, let's say if you had
I just picked that one because
the sine of negative 4t on the bottom, what could you change that into?
Negative
So that
sine.
was called a, an
I
equation.
believe we're doing right. I know it.
Negative sine of 4t. Because for sine, negative angles come out. And then sine of 4t, you could do more stuff with that. 4, you can think about, sine of double doesn't work like that, but 4, you can think of something doubled. 4 is 2 t's, right? So you could say that's equal to negative sine cosine. 2 sine cosine. That's how sine of double an angle works. But here I'm not doubling just t, I'm doubling 2t.
does that make sense? Because this would be like 2.
And if that wasn't what I wanted, I've still got more options. This one, you can do that again with. This is 2 sine of regular t cosine of regular t. And this one is cosine squared of t minus sine squared of t. You can keep using your identities cyclically. So don't forget that you've got all those options now. They can all work together. See you next time.
Because